Yeah, are we good? All right, I'll try to keep the sound effects as low as possible for the rest of the talk. So apparently, I'm the one stopping you from having food and drinks, and I chose OAuth as a topic, so that's probably that's not gonna end well. Put that away, yeah. But it's a short talk. It's 30 minutes, so if you've ever done anything with OAuth, you know that I'm not going to be able to talk a lot about OAuth in 30 minutes. It's going to be a small overview of a very few interesting things that I think everybody should be kind of aware of if you have anything to do with OAuth. Let's try to involve you. I know you're low on sugar and you need some food, but let's be active. What is the core aspect of OAuth 2? Does anybody know? Delegating authentication. That's an interesting answer. Anybody else? Does everybody agree or other answers? Sort of. Delegation is the core aspect would be delegation. So authentication is obviously a part of it, but it's not about delegating authentication. It's about delegating access to a client application to allow it to access your resources on your behalf. So a good example I often use is Buffer. So if you want to grab a copy of the slides, you can find them on my Twitter feed. They've just been posted, not because I've been tweeting right before the talk. No, I schedule my tweets, and it's an application allowing me to schedule my tweets. So in that case, whenever I want to connect a feed or an account to this Buffer application, what I do is I tell it connect my Twitter account, and it's going to ask me, I'm going to delegate access to that application, to Buffer. So it's going to ask Twitter to delegate access. I'm going to have to approve that, and after that, this application gets access to my protected resources. So it's not explicitly about authentication, even though OpenID Connect builds on top of OAuth to deliver authentication, but it's about delegating this level of access. Keep in mind that I'm talking about a client, but in OAuth terms, the client is the application accessing the resources on behalf of a resource owner or a user. So the client can just as well be a backend system. In this case, it is a backend system. So it has a front end. I configure that my schedule with the front end, but in the end, it's going to be the backend service that's going to be contacting Twitter to ask Twitter to post a feed in my name or a post in my name. You have a calendar feature and stuff like that. The other side of the story, just to make the introduction complete, is the Twitter aspect. And at Twitter, you have all of these different clients. So essentially, all of these clients have permission to access parts of my protected resources on my behalf. So I've given them access. I've delegated that access. If you want to put this on an architectural diagram, a very crude one of the crucial roles is this authorization server. So the authorization server is the one that does all the work in an OAuth flow. It's the one that's going to decide whether something is indeed a good idea to delegate. It's the one who's going to interface with the resource owner, the one who's going to issue an access token to access these resources. We have the client application on the left, and the client is going to want to access certain objects, certain resources on the resource server. So these are all very abstract terms. Usually this is an API being accessed, run by someone. That can be a third party like Twitter, but it can also be your own backend. So there are scenarios where you actually expose your backends to your front end using OAuth. Doesn't always make sense, but there's no way I can go into detail on that. So if you have questions, please ask me later. And then the third leg of the picture is essentially where the resource server and the authorization server have some way of verifying whether a request from a client is legitimate, yes or no. And that verification, again, can come in many different forms. It can be a verification of the signature on a token and using what's inside. It can also be a request to ask more information about what's going on to make your decision. And of course, this is very simplistic. In reality, the image is a bit more complicated. You have all kinds of clients, you have all kinds of resource servers, and you typically have, you can have multiple authorization servers, but that's usually not the case. This part here, that's essentially what the bulk of OAuth is about. It's about that delegation of access. OAuth doesn't really cover how the client accesses protected resources. It says like, yeah, you can give it that access token, and the resource server needs to check certain things, but OAuth doesn't really go into detail. And the step of accessing resources is the same for all kinds of OAuth flows. You have all of these different flows to achieve something like this. depending on the type of client and what you want to do. But this step is essentially very, very similar because you're accessing an API, in this case, on the resource server. And that is the setup for the talk, and that's what we're going to talk about. I'm going to talk about this mainly in the context of Angular applications. I'm going to talk about a few things that you shouldn't be doing, even though many of us probably are, and things that might be better to use towards the future. Small word about me. Jürgen already gave me a very nice introduction. I did a PhD in web security at the University of Leuven, and I've been giving trainings in security for a couple of years now. And recently I started doing that under my own company, Pragmatic Web Security. So essentially, I go to customers, to companies, I deliver a workshop on secure coding practices for Angular, for traditional web applications, whatever they actually need. And that's my job now. So I travel a lot. I do a lot of talks whenever I travel. This is a home game for me, which is actually very rare nowadays. I'm also organizing the SecOpDev course, which is it's a non-profit organization delivering a course aiming to teach developers about secure coding practices. If you're interested in that, it's in Leuven. It's a very nice setting. It's definitely recommended. Enough about me. Let's talk about OAuth. Let's dive in with the resource owner password credentials grant flow. So yes, if you read the OAuth spec, these are the actual names of the flows. These are kind of complicated if you don't really know what's going on. So let me show you in a diagram what's happening here, and then let's talk about the properties. So again, this is a more or less simplified view, but it gets the important details across. So we have a user who wants to delegate access to a client. That's the main setup. And essentially, in this flow, the client is going to ask the user to authenticate him or herself. So authenticate the user. He's going to get login credentials from the user, and he's going to use those credentials to log in or to authenticate to the authorization server. So that's one of the reasons that sometimes OAuth is associated with authentication, even though it's not exactly true. Anyway, if everything checks out, the client is going to get an access token in return and can use that access token to access protected resources. That's essentially what's happening in this flow. A question again. What do you think about this? Are we good? Are we bad? Yes. If the client wants to use stuff from Twitter, then in this case, if it would be buffer, it would ask my Twitter password to make the connection itself. Do we like that or not? No. No, not really. To be honest, well, let me first tell you this. This flow is actually deprecated. So, well, it's not officially deprecated, but everyone who is working with OAuth, who has a very good grasp of the specs, who is building these products supporting these flows, considers this flow to be deprecated, because there are some drawbacks, including indeed that the client would need access to the user's credentials. Let me maybe show you a few other problems. So first of all, asking for the credentials is kind of a forced scenario, because the spec explicitly states that this flow is only used or only intended for trusted clients, meaning that if Twitter would have both the resource server and the authorization server, and it would offer a Twitter client, then it's kind of okay, because Twitter knows the password anyway, so it's good. And that's the scenario that they envisioned with this, but people started abusing that, and we're essentially training users to fill out their password everywhere they see a login form that looks a bit like Twitter. Even though it might be a totally different application, they might be tempted to, oh yeah, just give my Twitter credentials. LinkedIn used to do this for a very long time. If they wanted to import your contacts, they asked you for a username and a password, and that's a very, very bad security practice. So that's definitely one of the things why this flow is considered to be deprecated. There are a few other drawbacks as well. One of the drawbacks is that a front-end application, a client application, whether it's mobile or web or whatever, can't really handle secrets very well. So in some OAuth flows, you can actually have a secret that the client can use to make certain things happen, to access or to use a refresh token, for example. And in this flow, the client cannot handle a secret. So the client cannot handle refresh tokens, implying that the client, when it loses access, because access tokens will expire at a certain point in time, the client will need to ask for your credentials again to be able to get a new access token. which is not very pretty. Or it has to store your credentials to do that in the background, which is even less pretty. And because of all of this flow is actually, well, today there are better alternatives, so this flow is considered to be deprecated. That's one of the first points I wanted to make clear, because many people still depend on that. And it's okay in a legacy aspect, so if you have an old application using this, it's not, doesn't need to be rewritten tomorrow to fix that, but new applications definitely shouldn't depend on this flow anymore. So let's talk about a prettier flow. Well, it's OAuth, so it's not going to get prettier, but let's talk about a less insane flow, let's call it like that. The implicit grant flow. This is the one that's probably most familiar. So this is the one that people know. It's heavily based on redirects in the browser to make something happen. And in this case, we have a client again, we have our user, and we have our resource server. So what's going to happen is that the client is going to request access. It's going to involve the authorization server directly instead of going behind the back and getting the credentials from the user. So the authorization server, think a buffer or a front end doing something with Twitter, goes to Twitter and says like, yeah, I want access to this user's timeline. And the authorization server is going to ask the user who he or she is. That's an authentication step. It's not part of OAuth. The spec even says like, we don't care how you do that. Just make sure that you know who the user is. And that's what's happening there. And then the authorization server is going to ask you like, hey, this client wants to access your timeline. Is that okay by you? And there you can decide either yes or no. Well, in theory, there are more options. In practice, it's obviously a yes or a no, which in most cases is yes. Otherwise, you wouldn't have gone to the whole trouble. And when you authorize the client, the authorization server does some magic with a URL. It's essentially a URL containing some parameters, and one of these parameters is the access token. And the access token is a thing that grants access to these protected resources. So at this point, your front-end application, your client-side web application, which can be a GSP page for all we know, it doesn't really matter. It's JavaScript code being able to access resources on your behalf using access tokens. And that is a very common flow in front-end or in web applications. It's built for web applications. Let's take a look at some of the problems here. Does anybody know, maybe? Yes? Well, do you want to eat today, or? It's kind of complicated. There's all kinds of different options. So the resource server will need to verify the validity of the access token. That can be either by calling the authorization server and telling them, like, hey, I got this access token. What the hell is this? What does it mean? And it's going to send back some information like, oh yeah, this thing is valid. It's for that client and it's for this user. And then the resource server can make a decision. It can also be a self-contained token. The other one is the reference token. Self-contained token is a JOT. It's signed by the authorization server, so you can do something similar there. There's a lot more to it, but that's the high-level view. But any problems with the implicit grant, or are we good? Yes?
Can't the access token be removed in this way? Can somebody take it out of the client and use it for another purpose?
Yes. That's a problem for every OAuth flow. So the question was whether the access token can't be abused if somebody takes it out of the client and uses it for other stuff. Well, I suggest you talk to Facebook. I think they kind of had a problem with that recently. But yes, absolutely. Access tokens usually are bearer tokens, so the one holding that gives access. A very good point, because it already indicates that access tokens are kind of sensitive, and yet they live in the client. But that's unfortunately the whole deal with OAuth. There's no real easy solution there. However, one of the problems here is that the access token is transmitted as part of the URL, making it part of the browser history, making it potentially easier to leak than storing it somewhere within the application. There's a few other things as well. If you do this on a mobile application, well, this is the only flow that works well with a public client without actually requesting username and password from the user. So if you do this on a mobile application, the redirect mechanism is a bit more complicated because a mobile app is not a browser. And there's something known as callback interception, where another mobile app can intercept the callback containing the access token and then do whatever it wants with the access token. And that's a problem. And the second problem is the one we had with the password credentials grant flow. We have no client secret because we're a JavaScript application, so there's no real way to use refresh tokens. And there are workarounds. So some people modify the flows to still use refresh tokens even though they're not supposed to, and then you get all kinds of weird things that are not supposed to happen, because an access token is sensitive but expires typically after a short period of time. A refresh token stays valid for a very long time, should not be used without that client secret. And there's a mechanism of silently refreshing an access token by going back to the authorization server and asking for a new one without prompting the user again to do the whole thing. But that depends on the implementation, whether that's available or not. It's usually, well, again, it depends, but often it's not available for the implicit grant flow, meaning that if the token expires, you'll have to do the whole dance again with the authorization server, and the user has to authorize this and go back and forth, which is, again, not optimal. Yet, that's all we had until about a year ago, 2 years ago, something like that. Because this is part of the original OAuth spec, since then they have added an addendum to the spec, like a new spec adding a new flow for certain scenarios where they actually counter certain problems. And this is called a pixie-based authorization code grant flow. And pixie is PKCE. It's very nice to pronounce. Reminds you of little elves, but that's not what we're talking about here. It stands for proof key for code exchange. And essentially what this flow allows you to do, it allows you to use this authorization code grant flow, which is the more secure option of OAuth, which is intended for backend applications that use the secret, which is fairly well covered for all kinds of problems. Well, with this modification, you can allow or use this flow on the front end as well in a client application. Notice that the browser became a mobile phone. It's intended for mobile applications that suffer from this callback interception, and this flow solves that problem. I'm going to talk about what it means for web applications in a bit. Here's how it works. So before we start, we generate this code verifier. And this code verifier is essentially a random string. Generate it and store it. And then you start the flow, and you start the whole flow with the redirect, but you include this code challenge in the URL. And the code challenge is a hash of that random string. So essentially what you do there is you follow the whole flow again, you initialize that on the authorization server, the code challenge is there, it's going to be stored on the authorization server, he's going to ask the user, is this okay? Yeah, sure, I'm well aware what's happening here, I approve. And he's going to redirect back. In this case, it's not going to contain an access token, it's going to contain this authorization code, which can be exchanged for an access token. Traditionally with credentials, here it's going to be a bit different. So you're going to send that back to the client, and the client is going to exchange this code from here for an access token in this request, but it's going to include this code verifier, this random string. So now the authorization server, these are the same, by the way, different endpoints, but the same server. The authorization server now has that string, and he can compare these two. He can see whether the client that is trying to exchange this code for a token actually knew this random string by comparing the hash of that random string to the random string itself. And if these match, then the client starting step 1 must have been the client doing step 7, or somebody stole this random string from the client, which is, well, if that's possible, then you're screwed anyway. So this doesn't matter anymore. And because of that, we actually know that we're talking to a legitimate client, and then we can exchange it for an access token. And this prevents or avoids the client needing to have the secret value to exchange an authorization code for an access token. And the beautiful thing here is that this allows the use of refresh tokens as well, because this flow does support refresh tokens, but a few words on that in a second. Are we good? All right. Did we start late? Otherwise I have 3 minutes left, so I'm gonna... All right. Food is gonna be gone anyway, so don't hope for that. No, it's not that long anymore. Let's take a quick look at some of the challenges we had before. So essentially all of these go away because tokens are no longer part of our history, because the token is sent here, it's an API call. So there's no history there, there's nothing keeping it in the URL, so that's already a good thing. And the code to exchange it is one use only, so it doesn't really matter if that is in the history. There's no callback interception attacks anymore because of this secret being stored in the client. So if another client would intercept the code, it would never be able to exchange it because it doesn't have this code verifier. This flow is designed to counter these attacks, so that's a good thing. We can use refresh tokens if we want to, so the other things are solved as well. So this seems like a very nice solution. Everybody happy? Yes? I don't know, but I don't think there's an expiration date, but the spec says it needs to be at least 43 characters. So if you want to guess that, that's going to take you quite a bit. Well, between 43 and 128 characters, so it's a big random code. But I like the way you think. Very good. So you might think that we're happy at this point. So this flow seems to solve all of our problems. Well, yes and no. I kind of sneakily changed the client to this mobile application. Mobile applications, they have some extra capabilities. They run on an operating system where they have access to some kind of secure storage. And because they have a secure storage area, they can use refresh tokens because it's going to be very hard to steal them from the secure storage area of your iPhone or Android phone. So yes, they can use refresh tokens, but web applications, if you want to use this as an Angular application, it's not going to be that easy because, let's face it, Angular applications don't really have secure storage. You have local storage, which is origin-wide. It's easy, if something goes wrong, it's easy to steal whatever is stored in local storage. And there are some ways you can improve that, but in general, it's going to be difficult. So there's no secure storage area for the refresh token. So there's no real way to use refresh tokens without credentials. Makes us very sad, obviously. So there is, however, a solution to the problem. So the problem lies here. We cannot exchange this access token securely. Well, we can exchange the code for a token, an access token, but not for a refresh token. So how do you solve this problem? What would be a graceful solution? Well, of course, you can always hack the flow and just do it anyway because it works. I'm good. It doesn't. No, I know how these things work in the real world, but that's why I'm trying to give you a better alternative towards the future. Well, one of the graceful ways to solve this is by adding this parameter to the URL when you initialize the flow. And essentially what you're doing with that is you're telling the authorization server, I want a new access token. So you're not using refresh tokens, you just want a new access token. And you're telling it, I don't want you to ask the user for the whole thing again, I just want you to try. And if it succeeds, if you still know who the user is, if you authorized me before, then we're good and you can give me a new access token. Otherwise, well, of course things go wrong and I'll inform the user that we need to reconnect his account to our front end. So essentially what we're doing is, we're adding this prompt equals none here. We're sending that to the authorization server, and the authorization server is going to check in step 3 whether it already has a session. So this is typically in a single sign-on scenario. The authorization server will keep track of the user for single sign-on purposes. And it does that typically with a cookie set in the browser. So if the authorization server still knows the user and still knows that it previously authorized this whatever client to access this whatever resource, then that is actually quite a nice way of enabling this kind of behavior. And that's how the spec envisions that this is supposed, how this is supposed to work. So you shouldn't be handling access refresh tokens in the client. It's very risky in case something goes wrong. But this way you can depend on this sort of long-term session here. And if that session has expired, then probably your front-end based access to the protected resource should also have expired. And that's the way or the reasoning behind this. Yes, yes, this is definitely an improvement on mobile applications as well. Essentially, it's an overall improvement. Not for traditional web applications where you actually don't mind handling the redirect for temporary access to show a list of Facebook friends, something like that. Doesn't really matter, but if you have a full front-end application, I believe that this flow actually makes more sense as well. So to put it into perspective, and I'm going to conclude very soon now. So essentially the user has this session with the authorization server, which is already the case with most of these products. They already do that kind of pattern. They already allow your session to exist for a longer time, avoiding you to have to re-authenticate again and again. And as long as that session is active, you can obtain new access tokens. To be fair, some products, some authorization servers do the same with the implicit grant flow. So they implement that feature there as well, giving similar properties you can do in the background with an iframe if you desire. It's just a bit less pretty, but it might work there as well. But if you can use this flow, the properties are better. The only problem with this, And that's the last point. I didn't make it red to not be too negative, but one of the problems is that Pixie support is still limited today. So there's this popular authorization server called Keycloak. It doesn't yet support this Pixie-based flow, so that's a problem. There are libraries for the front end, like in Angular libraries. They also don't support the Pixie-based flow. And again, this is not a criticism on open source developers building these tools in their free time, like Manfred is sitting in the back, looking at me angry. It's not a criticism because he does this in his own time, and if he doesn't need this flow, then there's no real reason to implement and keep maintaining it. But my job here is to raise awareness about the presence of these things, to make you very excited about OAuth, and he's always happy to accept pull requests if you implement support for this. So seriously, not a criticism, just an observation. Any questions? Is it what? Yes, there is a separate spec. It's called an OAuth flow for native applications, they call it, because when it was written, it was intended for applications having access to this OS level secure storage. But in the meantime, compared to what people have been doing with SPAs like Angular, this probably makes more sense to use there as well. Yes, it is spec'd. Go for it. Yeah, I know nothing about Oracle, so no, I'm gonna stay silent. Anybody else? Yes. No, the prompt none is something that needs to be supported by the authorization server, so that would be Firebase in your case. So I don't know whether they support it or not, but it's something that typically your OAuth vendor or open source developer team would need to provide in the authorization server. Yep.
I might have missed it, but at which point of the flow does the user have to put in his credential, or doesn't he have to do this?
That would be either here, so either there is an existing session, well, of course not with prompt as none. So if you have prompt as none, the user will not be prompted. So it either succeeds or fails. If you have, let me skip back to a non-prompt based flow. So here, the ask for approval, it's kind of a reduced version between authenticating the user first and then asking whether this client can access that protected resource. So the authorization server would handle that here as well. So I may have skipped over that detail, so thanks for asking. Yes, so if this goes to Google, then Google would say like, choose one of your 20,000 Google accounts to log in, and yes, and then in the end they create an access token for that account, probably an identity token as well, because Google supports OpenID Connect, and they would send that back with this mechanism. It depends on how it's initialized. Typically, yes, it's supposed to redirect because that's the clean way of doing things. Like you click login with Google and you go to an actual Google page. That's the nice thing. Sometimes it's framed as well, which is less nice. It can be a pop-up. It depends on the implementation and what the authorization server allows. With the prompt is none, that will be a background request. So that you can typically run in an iframe because there's no user interaction anyway. The problem of running this in an iframe, you can do that, and many authorization servers allow that, but again, you're training the user to trust some weird part fitting somewhere in the page, and that's not how this is actually supposed to work in a clean way. Yes? The redirect is cleaner. It ensures that it works properly. Yeah, one of the drawbacks with the pop-up approach is you'll need to extract the code or the token somehow and transfer it to the other application. It's a bit messy, but I'm sure that Manfred has some real-world opinions on how to do that in practice. But well, he looks really surprised now, so just ask him plenty of questions. He'll love that. I should not stay for his talk, probably. Yeah. Yes, that's one of the, well, nowadays people are like, oh my god, never use login with Facebook. I'm not sure whether it's that bad. Well, of course it's a trade-off, but yes, if you delegate it here, then this would be the place where a two-factor authentication fits in. So you can effectively delegate the implementation of two-factor to your third party. This is in the Google context. This would be Google. Of course, if you have an enterprise setting, this would be one of the, well, can be a Keycloak server running within your enterprise, handling all of that internally. But there are also plenty of commercial products offering things like that, including multi-factor authentication and everything that comes into play there. All right. To conclude, Jürgen sent around this very nice mail. I probably shouldn't broadcast this, but whatever. You get a discount code for my Angular Security Masterclass in 2 weeks if you want to. So you and the rest of the internet can get some reduction on the price. So enjoy that. And then I'm going to conclude with this slide. So I hope to see you there in 2 weeks. And this is the final slide. If you want to get in touch, I am very reachable. If you have questions, you can ask me now or during the line when we wait for dinner. And if you want to stay in touch, my Twitter is probably the best option. Has some useful information on various security topics. So thanks for being here, and I'll see you later.